Or good morning, or good afternoon, depending on where you are, ladies and gentlemen. My name is Valentin Zelenyuk. I'm a professor at the School of Economics of the University of Queensland. And it is a great pleasure and honor for me to help organize and moderate this important annual event of our school, the Colin Clark Memorial Lecture, delivered this year by Professor Diana Coyle from the University of Cambridge. I'd like to start today by acknowledging the traditional owners and their custodianship of the lands on which we meet today. On behalf of the University of Queensland, I pay our respects to their ancestors and their descendants who continue cultural and spiritual connection to country. We recognize their valuable contributions to Australian and global society. Personally, as an Australian and a Ukrainian, I also would like to express my solidarity with Ukrainians who are defending their livelihoods and lives as we speak, and thank you all who help them. I also would like to thank all the team that helped organizing this event. Before we proceed, a few housekeeping remarks. You will notice we have closed captioning enabled to make this webinar more accessible to all viewers. If you would like to turn this on or off, you can do so by clicking the live transcript button below and following the prompts. We'd also love to hear from our viewers today. So if you have any questions, please add them to the Q&A section below, and we will address them in the Q&A time. The lecture series is named in honor of the late Dr. Colin Clark, who was a UQ economics academic and whose work on national income accounting was fundamentally important to the development of macroeconomics and to the approach of John Maynard Keynes, Nobel laureate. While visiting Australia, Dr. Colin Clark accepted the invitation of Queensland Premier Forgan Smith to work with the government. He reflected on the opportunity in a letter to John Keynes, writing it was too remarkable an opportunity to be missed for putting economics into practice. In 1938, he was appointed government statistician, director of the Bureau of Industry, and financial advisor to the Queensland Treasury, and provided the state with a set of economic accounts in 1940. Besides his important impact on the government of Queensland, Dr. Clark also published in many journals, including top journals such as Econometrica and many others. Each year, a leading expert in economics is invited to present the keynote address. And this year, we're very fortunate to have Professor Diana Coyle to carry this mission. Professor Diana Coyle is the Bennett Professor of Public Policy at the University of Cambridge. Diana co-directs the Bennett Institute, where she heads research under the themes of progress and productivity. Her latest book, Cogs and Monsters, What Economics Is and What It Should Be, discusses how economics needs to change to keep pace with the 21st century and the digital economy. She was previously a professor of economics at the University of Manchester. Professor Coyle is also a director of the Productivity Institute, a fellow of the Office for National Statistics, and an expert advisor to the National Infrastructure Commission. She has served in public service roles, including as vice chair of the BBC Trust and member of the Competition Commission, the Migration Advisory Committee, and the Natural Capital Committee. She was awarded a DBE in the King's Birthday Honours List of 2023 for her invaluable contributions to economic policy and practice, as well as her unwavering commitment to public service. Professor Coyle, it's a great honor to have you here with us. We all look forward to your lecture. So finally, the floor is yours.
Thank you so much. And I'm just going to take a welcome to have this opportunity to talk to you today and So it's good morning from London and good afternoon to everybody watching in Australia. The motivating question for all of my research is, are things getting better? It's what we economists are supposed to be about. And that raises two further questions. One is, how do you measure what's happening? And the other is, how do you evaluate what's happening in terms of economic welfare or well-being? And the context for my talk today and this title is that things don't seem to be getting better in many countries. Productivity growth is flat, and yet we are seeing absolutely astonishing technology, advances in technology. Before I get into that, I just want to say a word about Colin Clark and why it's a particular honor to have been asked to give this lecture in his memory. He's an undersung hero of economic measurement. The kudos often goes to Simon Kuznets or to Keynes himself. But he did absolutely pioneering work. And I learned much later, in fact, through reading this very interesting biography, that he'd actually worked at my undergraduate college, Brasenose College in Oxford. And one of the people I used to meet at college reunions, an elderly, lovely elderly gentleman, was in fact his youngest son, John, who'd also attended. And Colin Clark also worked in Cambridge, which is where I'm now based, of course. You get the clear impression from the biography that he was a bit of a maverick, but actually mavericks are absolutely essential to the progress of scholarship. And so I'm just absolutely delighted to have been invited to talk to you today. I want to start by setting the scene for the kind of change that's going on in the economy. And a lot of the figures that I show you will be for the United Kingdom, but these trends are common across all of the advanced OECD economies. And so this is an image that I often show to summarize what's been happening. The title is Digital Transformation, but what the chart shows is the material footprint of the UK economy, including trade, taking account of imports and exports, per pound of GDP. And this has been declining pretty steadily over time for many decades now, 4 or 5 decades. And what this reflects is the shift towards services and intangibles in the economy, driven by a twofold structural revolution. One is digital technologies, which started being introduced at scale from around 1980, and the other is the energy transformation that's underway now. These are big shifts in what economists call general purpose technologies, and they're called general purpose because they lead to changes in economic activity across the whole of the economy. Now, this is not to say that stuff doesn't matter or land doesn't matter. And of course, that's something that was acknowledged in Valentin's introductory remarks. They matter a lot. There's a wonderful new book by Ed Conway, a British journalist, called Material World, that tracks exactly how certain materials are absolutely vital underpinnings to the modern economy. But what the chart says is that as the world has been getting richer, people are valuing more the intangible parts of what's going on. It's the ideas, the research and development, the design, the service quality, the personalization that we're all experiencing. And so this is the backdrop to some very fundamental changes that have been happening. And of course, they're still going on. We've since, what was it, last November or December, less than a year ago, been introduced to the world of large language models, or generative AI, as it's sometimes called. I loved this headline from one of the tabloids here in the UK last winter. We don't know what it means, but we're scared. Attack of the psycho chatbots, because everybody started playing with these technologies. Some of the pioneers, like Jeff Hinton here in the middle, have started warning about the existential risk these technologies pose to human society. And the panel on the right here is a chart from one of the many papers trying to predict what AI, this next installment of digital innovation, is going to do to people's jobs. And to sum it up, it says that a lot of the content of a lot of jobs will, over some period of years or decades, be absolutely transformed, which is the case of all technologies, of course, but this one seems particularly powerful. And there's a good reason to believe that it's another general purpose technology, because we're already starting to see some of the impacts of generative AI in a number of areas of the economy. One people often cite is drug discovery. Google DeepMind has made freely available software for looking at protein folding so that medical researchers can almost instantaneously do work that would have taken them decades previously. But there are other applications too. A lot of professional services have started adopting the generative models and the chatbots. In education, we're all discussing how do we make the technology work for us rather than against us? How should it change how we teach and how we assess students? It can help in supply chain coordination. So there's a wide range of potential applications. And in a visit to Silicon Valley just last month, I heard the people who are running these models say how much they're scaling up and how quickly. So this is another incredibly fast-moving bit of the technology. And in fact, there has been absolutely massive innovation since the mid-2000s. Here's a partial list. I'm sure there are many more. And the more you dig down into any specific sector, the more detailed examples you'll get of technological advance, often sitting on top of previous digital technologies. One particular turning point is the year 2007, which is now, of course, getting on for 20 years ago, but that's quite a short span of time in human history. And 2007 brought the launch of the iPhone, since when smartphones have become, in the advanced economies, almost pervasive. At the same time, we saw the introduction of 3G and 4G and beyond mobile phone networks, and Wi-Fi sitting on top of these networks. And also the kinds of innovation in market design that enabled apps and the app stores that have absolutely exploded. So we have these devices now that are multi-purpose, powerful computers in our pockets all the time and can help us with anything from booking train tickets to finding our way, to telling the time, to communicating, to sending email, and so on. And this means that there's been a transformation in how we spend our daily lives, with people now spending more than a day a week online. So it's affected consumption behavior, but also has led to a transformation in business models and the platform business model. So there are two questions that raises. One is, why don't we see this in the economic statistics? And we have a statistical collection system that doesn't capture very well what's been happening in digital and technology. But also, where's the productivity? If it's 20 years since that key moment of taking us all online all the time, then why has that not increased measured productivity in people's living standards? And that's one of the puzzles that a lot of my current work is trying to look at. One of the approaches we took to the diagnostics of the productivity problem was to look across different sectors. So this chart I'm showing you shows the contribution in percentage points to the slowdown in labour productivity in the United Kingdom, ranked by sectors of the economy. And if you look at the bottom, so you get a distribution which is somewhat weighted negative, as you would expect, because we've had almost no productivity growth. But if you look at the bottom, there are four sectors where actually there has been a lot of introduction of new technologies. Finance and insurance are heavily dependent on digital. Manufacturing, any area of advanced manufacturing, has for many years now been using computer-aided design and logistics. Information and communication, the leading digital sector, which here means computer software and computer services. And then agriculture, where although it's still heavily rooted in the countryside and manual labour, actually has been scaling up the use of technology quite dramatically, partly because of labour shortages. So this means that the puzzle has actually become even more intense, because these sectors are exactly the ones where we would think digital was being applied quite widely, and also because they're quite high value sectors. So this is telling us that even the sectors of the economy that we think are the successful ones, adding a lot of value, have made the biggest contribution to the slowdown in labour productivity. So that's even more puzzling. One natural question then to ask, if you look at economic statistics, is this something about how we're measuring what's going on? It's relatively easy to measure companies' revenues and add those up. But we want to divide those into what's the real increase in output in terms of quantities or volumes, and what part of it is due to price increases. Because we want to, particularly at a time of high inflation like now, we want to kind of abstract from the price increase part of the story. And so with a number of colleagues, I've been looking at what's happening to the price of different parts of the economy that might suggest that we're not quite measuring things properly, and that the real terms increase has actually been a bit bigger than would be suggested by this chart. So the first area that we looked at was telecommunications, where there has been, as any telecoms engineer will tell you, amazing technological progress. There's the move to fiber optics and Wi-Fi started this, wireless started this, but there have been improvements in compression, in reliability, in the volume that the cables can carry, and so on. So the engineers came to us and said, the price index that you have is showing that there has been no decrease in the price, but we know that there have been all these quality improvements. Shouldn't your price index take account of the quality improvements that have been going on in telecommunications? So we looked into the figures in detail and came up with a range of alternative price indices. The top line here is what used to be the official price index used in UK statistics. And all of the improvements that we could make showed a lower level, a bigger decline in prices, and that meant faster real terms growth than was being shown in the official statistics. The bottom line, the red one, is a unit value index. It shows you the price of a unit of data transmitted over the communications networks. Now, there are different prices charged for different types of service, texting versus voice calls versus video. So that's not a true price index, but it gives you a sense of both how much usage of data has increased, the number of bytes of data being transmitted has increased over time, because it's a 90% decline rather than the 0% decline shown by the official index. So the Office for National Statistics took on board the most cautious of these alternatives. That's the pale blue line in the middle, and that added 0.6 percentage points to UK GDP over a number of years, which, when you're not growing very much at all, is really worth having. So in that case, there was a little bit of a measurement artifact. We followed up more recently by looking at the price of ICTs, information and communications technologies, the sector that includes computer software and computer services, an area in which we think the UK economy is pretty strong. And so the next chart is a little bit complicated, but what it shows is the impact of a natural experiment in the UK statistics. When you construct GDP figures, you really ought to use different deflators for the price of inputs that companies are buying, the labor and the materials and the components that they buy, and the outputs that they charge. And the reason for that is that when profit margins change, those indices can move in different ways. So the best practice is to do what's called double deflation, to do the two separately. This was introduced in the UK a few years ago, and so we can compare the before and after figures. And the before figures are in the bottom two panels for manufacturing and ICTs, and the after figures are in the top two panels. The red bars here show you the contribution to labour productivity growth of the price change, and the blue bars show you the contribution of everything else that's going on to productivity. The natural experiment of switching to double deflation didn't make much difference in manufacturing, but as you can see from the right-hand two panels, it made a big difference in ICTs. It tells us that the gap between the input prices that companies in that sector were paying and output prices was making a negative contribution to their productivity growth. And that's a bit surprising, because if you think about the input prices in the sector, we know that one of those, the raw computing and communications costs, have been going down quite substantially. So why is it that the relative price changes were acting as a drag on productivity? that suggests the opposite. It suggests that input prices are rising relative to their output prices. So again, there seems to be a bit of a measurement phenomenon going on here. We followed up with a new paper looking at, well, actually, how much does it cost to do computation? How much has that cost fallen over time? Because that must have been the driver of the digital revolution. In a famous paper some years ago, Bill Nordhaus, the Nobel laureate, looked at the engineering side of this question, looking at the cost of different modes of computing over time. And this is a chart from the paper that he published then. It's got a logarithmic scale, and so a straight line is showing you exponential decline. But this is the cost of computing was pretty stable up until the post-war digital revolution, and then started absolutely plummeting. And this reflects what is known as Moore's law, that the a number of chips that you can fit on the number of components that you can fit in a chip doubles every couple of years. I'm slightly distracted by my dog barking in the background, so apologies if I can't hear that. So these costs have been plummeting up until 2010, which is when his paper came to an end. We've extended this by looking at modern computer chips and different benchmarks to see, has that rapid decline in the cost of computing continued since the introduction of the smartphone era? And here's another complicated chart whose answer is basically yes, it has continued. Again, this is a logarithmic scale. I'm showing you different benchmarks because the modes of computing have changed somewhat, but all of them show you, first of all, that the decline in costs kept pace with Moore's law up until around 2015, so relatively recently. Some of them have since flattened out or reversed a little bit. Moore's law is the darker dashed line in the bottom. They're also declining much more rapidly than the official price index for the computer chips that anybody in the sector is buying to do the activities that they perform. This shows one kind of computer chip, CPUs. There's another kind, GPUs, graphic processing units, which have since become much more common and are widely used in AI. And so we wanted to try to patch in these GPUs as well. Did that make any difference? Has that actually increased the costs because they are much more sophisticated chips? And the answer is, well, those costs have been falling as well. And again, kept pace with Moore's law up until around the mid-2010s. And then when you put them together, the CPUs are the red line, the GPUs are the blue line at the bottom. All of these tell a tale of continuing rapid decline in the cost of computation, and much faster than the decline in the official price index for the costs being paid by companies in the sector, which is the dotted line at the top. So that's a kind of quite complicated story, but all of the details are now in a published paper if anybody's interested to follow that up. A final bit of a story about the costs of being in that sector is the use of cloud computing, which has been spreading extremely rapidly. That tells us on the face of it that it's an attractive option for companies rather than investing in their own servers and webmasters and so on. But there's no official price index for cloud computing. We constructed one by web scraping Amazon's Web Services website over time using the Wayback Machine to find out what prices had been charged for certain products. It's a complicated activity because there are lots of different products on offer and they change over time and there are bespoke deals. But anyway, we found that the cost of cloud computing has also been falling quite dramatically. Most of all, when competition first entered the market, Amazon Web Services used to be the only one. Microsoft got into the market at scale in 2014, but the costs of cloud computing is still coming down as well. There is actually a competition inquiry going on into that market now because that decline seems to have eased off. But the overall story is that computation, measured by any kind of natural unit of measurement of computational activity, is almost free by the standards of a decade ago and 2 decades ago. And that means, of course, that there's very much more of it. The demand has increased accordingly. This tells us that maybe there is some measurement artifact going on here as well. We know this is from a survey by Ofcom, the regulator here in the UK, that demand for cloud computing is increasing. The ChatGPT and these large language models are taking the world by storm, as this headline says. This is a comparison of the speed at which different technologies got to their first million users. So if you look at the bottom, 150 days for Spotify, 75 for Instagram, just 5 days for ChatGPT about a year ago to get to its million users. So the use is extensive. You're probably using it without knowing it because it's already being tied into certain products, including regular search, all the Microsoft suite of products that so many of us use. So we will see both the integration of generative AI by the big tech companies, but there's also a huge range of startups building small models or building APIs on top of the large language models that are generating a whole range of innovative activity. And we're going to find it's being integrated into lots of everyday services, such as call centers, online banking activities, health and health. So let me just pause and sum up where we've got to. I've said to you that there has been amazing change in the technologies, and that's continuing. But that's not being reflected in the productivity numbers, either for the UK or for other advanced economies. Productivity growth has slowed down substantially. There are many reasons why that might be the case. We've got aging populations in many cases. There may be some overhang from the financial crisis. There have been subsequent huge shocks to the global economy. So technology is certainly not the only part of the story. And I've also said to you, there are, though, some measurement questions. I've picked on two, and in the grand scheme of things, they're relatively small. Correcting the official price indices would improve measured productivity a little bit, but it's not going to be the whole story. But it points to a bigger question about the way that we're measuring the economy. One of my lecturers many years ago was Zvi Grilikus, who was an expert on the diffusion of technology and productivity questions. In a paper he published in 1994, he said, one of the reasons we're finding it hard to understand what's going on with productivity, which had at that stage also experienced a slowdown, is that we just can't measure the economy very well. And he produced a table that was the first 5 columns of this one here up to 1990. He divided the economy into what he called the measurable and the hard to measure sectors. So the measurable ones, agriculture, mining, manufacturing, transportation, utilities. We'd probably now put some of utilities, which includes communication, into the hard to measure, but I've left that be. And then the hard to measure is where it's hard to understand the division between volumes and prices, where there's been quality change, where there are lots of intangible activities. So even in 1990, only a third of the economy, a bit less, was what he defined as measurable, and 2/3 hard to measure. By now, 4/5 of the economy, which is the update that I've got in the table here, and if you take that forward, that trend has continued. £4 or $4 in every 5 are hard to measure. And that to me says that if 4/5 of the economy is hard to measure, we're doing something wrong with the way that we're trying to measure it. And so this is how I crystallize that question. Why can't we see the impact of this fundamental restructuring of the economy? And it's because it's not being used only to do the same things we did differently. It's being used to do different kinds of things. We're trying to fit economic measurement for the 21st century into at least century-old concepts and constructs, and that's just not working very well. So let's step back and think about what productivity really means. It's very easy to think about it in terms of gadgets, the shiny iPhone or Android phone that we've got, or some app on the phone. But really, productivity is a story about improving the processes of economic activity and not the products. Products matter, but processes matter more. And if you look back through economic history, Each stage in the industrial transformation of the economies, the Industrial Revolution, first and second industrial revolutions, have all been about process transformations. The American system of manufacture was the invention of interchangeable parts produced by increasingly sophisticated machine tools. The factory system, building large factories around steam engines. The assembly line, using electricity to reorder production into a stage-by-stage process. Just in time in the late 20th century, using the early digital tools like computer-aided design and early telecommunications. The production networks that have transformed global economic activity since around 1980, and most recently, digital platform models. And any new business that starts up pretty much is going to use a digital platform model. At each of these steps, there has been increasing specialization. So many companies now have very specialized activities, and also increasing returns to scale. So the market size for each stage in the process has grown bigger and more global. So globalization itself has been part of this process improvement. And it's what Adam Smith talked about originally in The Wealth of Nations, that the division of labor, specialization, and the increasing scope of the market were those drivers of what he called universal opulence. Now, at the moment, though, using the new digital tools is something that only a few companies seem to be doing successfully. And there's now quite a lot of work, this from an OECD paper, showing that it's the frontier firms that are making the technologies work for them and increasing their productivity. So the left-hand side is manufacturing, the right-hand side is services, the top panels measure labor productivity, the bottom panels measure multi-factor productivity, which takes account of all of the inputs that companies use. And for it's now getting on for 20 years, the frontier firms, the top 5% of firms by productivity, have been pulling further and further ahead of the rest. Now, this is another restatement of the productivity puzzle, if you like. The question then becomes, why aren't more firms able to use the technologies? But if I think about the implications for understanding productivity, it raises a number of really challenging research questions. First of all, we think about revenues equal to price times quantity, but for many activities in the economy, there aren't natural volume units, natural quantity units. You can't think about most of the economies being like cars rolling off the production line. How do you measure the quantity of management consultancy is surely not by the length of the PowerPoint deck they've got. Second problem is that price often signals quality improvement, and it's quite hard to take account of that. And it also signals market power, because in many markets and many economies, we're seeing increasing concentration and profit margins of those frontier companies going up. Production itself is either very specialized because companies fill one of the slots in the chain of production networks, or it's a bigger company that's bundling together different kinds of output. And it's quite hard to attribute value to those components of the bundle separately. And then we need to understand why some firms are doing so well and others are not. And the answer seems to be that what are called intangibles, things like the know-how that resides in the firm, the way it's organized, the quality of management, the brand value, all of these intangible assets are a key differentiator between companies. And the successful ones are probably more different in their intangibles than they are in anything else. So what you're seeing is an extremely common phenomenon of companies bundling different things together. And the word for this in business is solutions. You see this all over. IT solutions is a company that will provide you with your computers and devices, all your connectivity, but also the software and the services to back that up. Gardening solutions, they'll buy your plants, they'll do the digging, they'll design it for you, they'll contract the maintenance for you. Similarly with all kinds of others. Office furniture solutions don't just sell you furniture, they will design your office, they'll provide the furniture, they'll maintain it, they'll replace it when it breaks. So all over, you're getting solutions rather than products, even in some of the most surprising places. So kebab solutions buy you your ovens and machinery, but they also provide the ongoing inputs and the maintenance and so on. So you get the idea. It's the services around products that are part of the economic activity. So I'm winding up with really a series of future research questions. I'm not able to answer the question I posed right at the start, why is productivity growth so low? But I think the journey points us to some areas of research that as economists, we really need to think about. One is, why is it hard for companies and other public sector organizations, in fact, to adopt digital tools? There is something about, it's not just buying the software and the hardware, but how do you organize the use of the tools? How do you restructure your activities? How do you upskill your workforce? There's something difficult in that, and we ought to understand why. What data do we need? So I mentioned earlier, we just don't have official data on cloud services, which almost all companies in the economy above a certain scale are using now. And in fact, we're all using it through Gmail or similar products. How should we start to classify data when we collect it? Because we have production networks, we've got firms offering solutions, we know that jobs are going to be affected in terms of the tasks that people do rather than the actual jobs that they hold. A question of interest to me is, should we start thinking about time as a measure of productivity? Because one of the things that digital technology enables is to speed things up. If they're routine, we ought to be able to do it really quickly and easily. And if there's somebody who can routinize my domestic tasks and make me save much more of my time in the way that the washing machine in the 1950s and 60s saved so much time of women involved in care in the home. And then following up on the slides I showed you earlier, should we revisit price indices more broadly? What is it that we want to understand the price of? In my telecommunications example, it's not really the price of a byte of data that's interesting, because we're not interested in the raw data, the raw bytes, the volume. It isn't really the price of the telecommunications network, because that's just the vehicle. It's a derived demand. We value the content. How do we divide up the value that's being generated there, which is in effect the net neutrality debate that's going on in many economies. So I've ended up with one big question. I've divided that into a series of smaller questions, and I'm sure there are many more. I want to end by thanking some of my co-authors on this recent work, who have been working with me at the Bennett Institute, and thank you as well. So I'm going to stop screen sharing there and hope we got some time for your comments and questions.
Thank you very much, Diana, for fascinating lecture. The first question, if not already, do we think there would ever be consideration to measuring productivity in the 21st century that includes a view on effectively measuring invisible domestic labor, as suggested by Dame Marilyn Waring?
It's a great question, and the short answer is yes. There are economists who continue to work on what you call invisible labor. I mean, for any of us who've been doing that domestic labor, it's anything but invisible. And the debate about whether to include unpaid labor in the household actually goes back to the dawn of the national accounts that we use now, and the decision was taken to exclude it. I think the question has been re-emphasized by some of the digital changes, actually, because they have shifted some paid activities over the production boundary into the household. So you can think about things like doing online banking or travel agency, which is substituted for going to the high street to talk to a travel agent or into the bank branch. There's a lot of voluntary activity into the form of creating open source software, participating in online communities of creating medical technologies and so on. So there's a very large digital invisible domestic labor sector now also, which affects official productivity measurement. But to answer more directly, I think one of the interesting approaches to understanding productivity is to think about it in terms of time. And I did hint at this right at the end there. There are some things that we want to speed up, both in domestic work and in paid work. And there are some things where the time spent is either enjoyable or intrinsically valuable. If you think about medical care, for instance, some things have become quite routine. We want them to be as fast as possible and not take up too much people's time. And then other things like caring for the patient or intensive care, then the number of quality person hours spent is the actual productivity metric. So I think thinking about time rather than money as the measure of productivity is a really interesting approach. And it's something that I have begun work on. I have one paper on this with Leonard Nakamura, which is not too technical a read if anybody would like to look that up. It's a great question.
Thank you, Dan. Next question from Teneke Wedmeyer. Apologies if I pronounce the name incorrectly. So I will read the question. This is a bit of a stretch, but do you think there is a connection between a shift towards more service-based product delivery and the idea of the circular economy becoming more mainstream, especially in the EU? Are the frontier companies that are driving productivity seeing value in the preservation of resources used in production?
That's a very interesting question, and not one I've thought about. So this is going to be an answer off the top of my head. You would expect that moves towards greater energy efficiency or a circular economy would be a no-brainer for companies because it is going to save them costs. It's already the case that generation by renewable energy is cheaper than fossil fuel generation, particularly since the energy price hikes that we've seen. And there seem to be some barriers to making the switch, which I think are entirely understandable. Once you organize a business in a certain way, if you want to change to a new technological basis, change people's jobs, the tasks that they do in their jobs, perhaps change the source of your inputs, your whole supply chain, make some investments, that's quite a big step. And the prospect of the cost savings and the increased productivity has to be big enough to outweigh the adjustment costs, if you like. And that's why often there are delays in switching towards new technologies. And that may be part of what's going on now. But I think the presumption behind the question that the ability to make these kinds of structural transformations is what's dividing frontier firms from the rest is certainly likely to be part of the story. So I would agree with that presumption.
Okay, thank you, Dan. Next question from anonymous attendee. Is the paper you mentioned with Leonard Nakamura titled Toward a Framework for Time Use, Welfare and Household-Centric Economic Measurement? ?
That's the paper. It's in a journal called International Productivity Monitor, which is open access, so anybody can read it.
Okay, good, thank you. Next question from David Wadley. A comment. I think that your emerging emphasis on process engineering is appropriate. All materials processing involves intermediate products transacted on a business-to-business basis, but the focus seems to have been traditionally on consumer goods or services. So a shift into basic production economy seems timely. That's a comment. Would you like to respond?
Yeah. Thank you for the comment, David. And I do think it's a really interesting area because the shifts in technology and organization are shifting relationships among businesses. And so in many areas, you see these tussles over the allocation of value going on. I've also looked a little bit at construction and the process of digitalization in major construction projects. And there are contractual issues over who gets the benefit of the sensors that you can spray into the concrete in a major project that will save downtime and maintenance costs when it's finally in operation. The net neutrality debate is a similar one. So I think it's a fascinating set of questions.
Thank you, Dan. The next question is Professor Prasada Rao, our colleague here at the University of Queensland. Are economists and statisticians considered by the current tools like SNA at their disposal, question mark. Does measurement in the presence of a large digital economy, is there a need for a new toolkit? Where do we start?
Thank you, Prasada, for the question. And I suspect you'll know what my headline answer to this is going to be. I don't think the SNA is the right framework for measuring what's happening in the economy now. It's a framework that suited the economy of the mid-20th century. But where to start is the difficult part of the question. And for me, it starts in thinking about the classifications of activity. Partly the production boundary that we were talking about earlier between paid and unpaid activities, and how do we understand where that ought to go, or how to think about measurement on each side of that production boundary. But also the classification of the basic units. So we tend to think in terms of sectors. Should we think in terms of supply chains? Should we be using new types of web scraping techniques to have different kinds of classification emerge from the data from how companies describe themselves and what they do? Although I guess that would mean that solutions was the biggest sector of the economy. So I don't have an easy answer, but on the other hand, developing the system of national accounts that we use now took some decades. And so I wouldn't be surprised if this took some decades too.
Thank you, Diane. The next question is from David Cousin. In fact, two questions. With the difficulty in measuring productivity, are we ineffectively measuring emerging economies which are still based on the industries of the old metrics? And second question, is their productivity deceptive against potentially advanced economy? Hard to measure productivity, question mark.
I'm not an expert on emerging economies. And I think the first part of the answer has to be that we don't even measure what goes on in current national accounts terms particularly well because of data capacity, statistical capacity questions. And there are a number of really interesting books about that. One of the other issues has always been the size of the informal sector in many emerging economies, which is by definition almost not tracked particularly well. For low-income economies with not very large statistical offices, I think using new techniques, satellite data, mobile phone data, and so on, has to be part of how we improve productivity measurement there. I'm a bit concerned that as we try to improve digital measurement and we layer, and for that matter, natural capital measurement, we layer on more requirements on statistics, actually the ability to measure what's happening in low income and emerging economies will be even harder, but it's not an area that I specialize in.
Okay, thank you, Diane. The next question is from Professor Alicia Rambaldi, also a colleague at UQ. Thank you, Diane, for a great talk. We are making a lot more use of administrative data and hoping they will allow us to improve official statistics. However, a number of measurements arise from accounting practices, business taxation, compliance. Can they measure process or solutions, question mark?
I think there's a lot of potential for using different kinds of administrative data. The official administrative data is increasingly being folded into national statistics. We do need to look more to management accounts to understand things like the use of cloud computing. But I guess there too, the problem for economists is that the way that companies think about what they do doesn't map very well onto the concepts that we think of as economists. I spent some years on the Competition Commission here, and whereas we think about productivity, for many companies, they might think about KPIs or revenues. They've got different kinds of metrics, and the national accounts are, to some quite large extent based on financial accounts already. That could happen a bit more, but I don't think that addresses the question about have we got the right concepts for thinking about the economy.
Thank you, Dan. The next question is from Leonora Risse. Thank you, Professor Coyle. To what extent do you sense that an undervaluation of care work, and more fundamentally, the gender norms that underpins this, is contributing to the mismeasurement of the aggregate productivity? Question mark.
I'm not sure I can put a number on this. It's pretty clear that if you look back over what happened in the 1960s and 70s, official productivity figures were greatly augmented by the shift of mainly women from working at home to working in paid employment. And it's not just that their jobs then got counted, it was also things like purchasing consumer equipment like microwaves or ready meals and so on, or hiring people to do your domestic labor for you. But quantifying that is quite tricky. And so equally, quantifying what's happening the other way is quite tricky as well. My strong intuition is that it's a very large effect on measured productivity. We spend many hours a day in unpaid work, and all of the attempts looking at household accounts and using labour market wages to estimate the value of that put it at around the same size as GDP, roughly speaking. So any implementation is going to make a big difference to the numbers. I just don't know how big that is. But the fundamental point of the question is, do we need to think about unpaid labour if we're thinking about economic progress? And the answer is yes, absolutely. And I hope that the people working in AI and robotics are thinking about the household sector as well, and how can they bring about productivity improvements in the household as well as in the workplace.
Well, thank you. Next question is from a colleague, Professor Kevin Fox, colleague at the UNSW. Professor Kevin Fox. Great talk, Dan! Exclamation sign. Dan Sichel and Eric von Hippel, 2019 paper, argue that a lot of innovation happens in the household. Do you think part of the productivity slowdown could be due to new digital products, people spending too much time watching TikTok and less time developing new products and new ways of doing things? Question mark.
That's an interesting question. So one of the measures of progress is that we get more leisure time. The number of hours worked have declined quite substantially in most countries as they got richer. And so if we've got more leisure time, but we're spending that watching TikTok videos, then I don't think there's any great productivity implication to be drawn from that, except isn't it great we've got more leisure time because we've become more productive at work and we can afford it. But there's also a question about, at work, are the tools that we're using making us more or less productive? And here I think it is actually less clear. And it's not so much that people are sitting at their desks when they should be working, they're watching videos instead. It's the proliferation of activities that you do online that are actually not very productive ultimately. And we've all had the experience of the torrent of email growing bigger and bigger, and people sending messages when, maybe they don't have to, or they would once upon a time have just asked you a question when you were standing making your cup of tea. And I think the jury's out on that. I don't know to what extent there's some kind of fundamental drag on productivity from those increments to process that have come about because we can do them because of digital.
Yeah. Thank you. We come close to the end. There's one more question at least. So you give very interesting picture about the past and also about the some insights into the future, which probably is uncertain, maybe exciting, but maybe in some sense scary. Now, what do you think will be or should be the role of universities to help with the future progress or to avoid the regress, at least, especially considering all the challenges the universities are going through, such as, for example, excessive bureaucracy, excessive teaching loads, and what seems to be much less research time, and many other challenges. So what the university should do, in your opinion, because you're also an academic, so What do you think?
Yes, well, of course, we've all been focused on what difference does the generative AI make to how we do things at the moment. Does it undermine our ability to assess students because we're asking them to turn in essays, but they might have had those written by a chatbot? There's not so much thinking about how would we dramatically transform the way that we provide education. My instinct is that it's going to make what seem like quite old-fashioned modes of education more important. We can ask students to do more online. We can do the flipped classroom model and have them do work, but come into the classroom to discuss it. I think those person-to-person encounters will become more important, will have to become part of our mode of assessment. What I'm hungering for, and if only I had time because of the teaching and research loads to do it, is how can we use AI tools to simplify all those processes that have eaten up a lot of time in universities, but many other public sector organizations. So in healthcare in the UK, in local government, the accumulation of process has become a real burden, and there should be a golden opportunity to use the new AI tools to improve productivity across the public sector by lifting those burdens from people and freeing up their time to do much more valuable activities. I haven't got the answer to that, but as soon as I do, I will share it widely as an open source resource for all of us to use.
Thank you very much. Thank you, Diane. One last comment from me and a question. I think you've been, many would agree that you've been a great example of women in economics and in general, and how they can bring the academic knowledge into the government and help the government to run the country and improve. Can you give some examples to some advice to everyone, also men and women, and especially women, how to do their best, like you did?
Well, I'd encourage young people to study economics because it gives you a great set of tools for thinking about a whole range of problems, whether your interests are in business or in the public sector or in working in development. And it's a set of skills that you can take across sectors as well. So I've worked in government, as you said, as well as in universities and in the private sector. So it's a great discipline. I would encourage people to realize that it's not just about money. I think a lot of young people are put off because they think it's about making money and getting a job in financial markets. And of course, it's much, much more than that. And I found it absolutely fascinating. Every day is interesting. As academics, you learn much more from engaging with businesses or with governments. And so I think my research has been very much enriched by that varied path. But really, it's just a great platform for making your contribution to the world, having an absolutely fascinating career, and having that amazing flexibility, which actually ought to be a benefit for women. So it's a very male-dominated profession, but for any women who are thinking about what to do in their career, any young women, this is a great option.
Thank you very much, Diane. I will certainly pass it to my daughters for sure. Thank you, and I'm sure others also will benefit from this nice advice. I see that we are running over time. I wish we could continue with our Q&A sessions, but hopefully some other time. And at this moment, I would like to, Professor Coyle, again, thank you very much for your fascinating lecture. It's been a great honor to have you here with us, although virtually, but hopefully someday in person. And we hope there will be more opportunities like this indeed. I also would like to thank our marketing team for helping organize this, what I think is very interesting event, as well as thank all the participants for their attention and questions. And we hope to see you at our next events. Thank you all and have a great time.